Welcome to TrustGraph. Today we'll be talking about why TrustGraph is an important protocol, similar protocols in the space, and also talking about a brand new TrustGraph library that we're releasing on Holochain, which I am very excited about. I'm Harlan Wood. I've co-founded a few startups, worked at a number of startups, and occasionally speak. Might have seen some of you at DWeb and DWeb Camp in the past. So going way back to 2011, we had this idea called Trust Exchange, which later became TrustGraph, of doing decentralized trust and reputation systems, along with decentralized creative collaboration systems, which we called wiki nodes, ultimately leading to Core Network, which is a decentralized visualization and sense-making platform, which is the core of what I'm working on today and what we're building out TrustGraph on Holochain in service of. So we're not the only ones who have similar ideas about decentralized trust protocols. Back in 2014, IETF released a series of RFCs around reputons. I said that we started ideating on TrustGraph around 2011, but we wrote some papers and released some repos around 2016, wrote some papers in service of the Rebooting the Web of Trust workshops started by Christopher Allen. And more recently, in 2020, TrustNet emerged. One really exciting facet of these three projects is that they're largely extremely compatible. To my knowledge, none of these knew about the others while they were in development. And yet, they essentially have four core fields that are very much in common. The source, the target, some semantic content, could be a tag, I trust someone in their taste in Thai food or their blockchain research abilities. So some specific trust area. And then some kind of scalar weight called by different names in the different systems and using slightly different ranges. TrustGraph uses negative numbers for spam and abuse. And some of them have optional attributes, user-defined or well-defined. But the exciting part to me is really how much they all have in common, and therefore how you can morph between these. And also a shout out to Fluence Labs, one of the sponsors of this Web3 track, which also has a TrustGraph project. The only reason that I didn't include it in this matrix is that I don't understand it deeply enough yet, and I'm not sure whether it's at the same level of the stack, but excited to learn more. So why TrustGraph? Well, some of the use cases that systems like this can help with and perhaps solve or help us solve are peer-to-peer credit ratings, claims and evidence that can help us get out of this quagmire of fake news, cryptographically signed ratings at every stage of the supply chain, refugee credentials, decentralized academic peer review. These are really just a few of the many, many use cases. Another is a kind of better search results. What's better than Google when you're looking for sushi around you? Well, it's if your friends and people you actually trust in sushi or food have recommended things, that's better than Google or Yelp, etc. Moving on. What TrustGraph is under the hood is cryptographically signed claims. And so those are claims that are essentially ratings, reviews, any kind of likes, reputational data in general. So the claims are in an open format, which we've looked at a little bit. Very importantly, they're immutable and cryptographically signed. So they play very well with blockchains, holochains, the Web3 world. The claim can target anyone, a person or entity, or a restaurant, a corporation, etc. Can be a public key or URL. And claims can be shared, but importantly, can remain private. Private to an individual or private to the group that you choose to share them with. So TrustGraph is very much at the platform level. That is to say, it's unopinionated in the way that HTTP or HTML is unopinionated. You can put whatever you want at the application level into the semantic parts of the trust graph. Also importantly, trust graphs are agent-centric, meaning that when I look out at the trust web of blockchain research, I see something completely different than what you see based on who we trust directly and who they trust through their TrustAtoms. And we'll get to the down and dirty format of the TrustAtoms a little later, but it essentially comes back to those 4 fields we looked at. So TrustGraph is a reputation interchange format. Interestingly, that's also words used by IETF Reputons and also the emerging Neighborhoods project, which is building on Holochain, which can absorb heterogeneous reputation and ratings. So any kinds of ratings, reviews, likes, claps, etc. And finally, really importantly, this is potentially a foundation for decentralized applications, social networking and otherwise, to share data and information in an agent-centric, self-sovereign identity topology. And that's really important to me because we see decentralized social networks creating their own de facto silos and silos of reputation data. And I believe that TrustGraph signed claims can be a big help for that. So we're going to take an example. A decentralized application that is a punk rock record store, taking us back. So we've got Alicia's trust graph at the top, and she trusts Beth in certain areas. Notably, she trusts Beth's taste in punk very highly, but new wave not so highly. So all of these TrustAtoms have a source and a target, and some of them have a content and a value. Some of them only a value, some of them neither. And that's important because an application may want to not ask a user for additional information. Given Alicia's trust graph, this punk album will percolate up to her much more strongly because of her trust in Beth's punk tastes, whereas this new wave album, not so much. Now also, trust graphs can point to other trust graphs, again, through TrustAtoms. So the punk rock record store itself has a trust graph, which it's not shown here, but that could be sourced from admins of the record store, from music critics, etc. And Alicia's like, well, punk rock record store is pretty good. She doesn't put in a content because she's effectively saying all of what they recommend can percolate up to me, but I only trust it to a certain extent. Not like I trust my friends in some areas, 100%. And so what we'll see in the next slide is the roll-up, the combination of all of these TrustAtoms from Alicia's point of view. Let's go there. So now the entire previous slide is what's grayed out here, except for these bottom leaf nodes, the albums that all of these trust graphs were pointing to. And what we see across the top is the roll-up TrustAtoms. So Alicia's trust graph has computed TrustAtoms for each of the semantic characteristics within her trust graph. The reason that all of these are marked XX% is to indicate that TrustGraph doesn't have an opinion on how you're going to do the rollups. The idea is that that is actually quite application specific. And one of the cool things about having this rollup layer is that it's very fast. That is to say, when Alicia goes to Punk Rock Record Store, the system doesn't have to crawl down through multiple levels of trust graphs, which could be, 3 or 6 levels. It's already been rolled up to these top level TrustAtoms, which are kind of Alicia's cache of her most recent view into the trust graph. Now, this is just one way of using TrustAtoms, but it's a really powerful way to think about it. So next, let's talk about trust graph on Holochain. So we've been cooking up really the first publicly released software from the trust graph project on Holochain in service of projects we're doing there. So recall that TrustAtoms have a source and a target, semantic content and numeric value, and additional attributes, which are user-defined and optional. And so a concrete example of that is Alicia has a rating of Sushi Ran, a restaurant in the Bay Area. The content is sushi. The value is 0.75 technically. And she has a full review in her additional attributes and perhaps an original rating. And what that's pointing to is that this might originally be a star rating that's being imported from somewhere else. And so we can have information about that so that we can use that and treat it differently than other 75%, perhaps, again, based on it in an application specific manner. Now, we're talking about the Holochain library. And so let's talk about the Holochain link format. So Holochain has 2 major components under the hood. In the distributed hash table, there are entries, content addressable entries, standard DHT, and there are links between the entries. And those links are very lightweight, and we're using the links themselves to represent TrustAtoms, actually a pair of links for each or most TrustAtoms. The link tag has about a kilobyte of space available. And so we're putting all of the rest of the data, notably the value and, the content and value, into the link tag. And we're going to look at this in a little more detail, but there's kind of a header, some header bytes, which are the trust graph T that kind of uniquely identify it, at least in the world of links with UTF-8 string tag representations, a direction, couple of bytes, the content, null byte separator, and then in the next slide, we'll see why we're spelling out all of these digits. But it essentially comes down to making these Holochain link tags searchable. And what you can do in Holochain when you're searching for links is you can search for leading bytes. So I could search for all of the sushi ratings, all of the sushi ratings above a certain percent, etc. And then there's some random for bucketing purposes, and optionally an entry hash where we'll find the additional attributes. And so we make an additional entry for the attributes. So a little more detail, or a little more by way of example, about these link tags, because it's really the core of the Holochain trust graph format. So I mentioned earlier that each TrustAtom creates a pair of Holochain links. And so one is a forward link and the other is a backlink. And the reason for that is that in Holochain, you can only search on the base of the link combined with the tag contents or leading bytes of the tag. You cannot search on the target. And so sometimes we want, as a friend of Alicia's, sometimes I want to see all of Alicia's ratings. But sometimes I just want to see all the ratings of sushi ramen. So I want to be able to search by either the source or the target. And so we make one link in each direction so that we can search in Holochain for both. Now, we're trying to illustrate here an example of why the numeric portion is formatted as it is. And that's so that I can say, hey, give me all of the sushi ratings that are 5 nines, right? That are 99.999% or above by searching this many bytes. Or we can back off and say, hey, I only got 2 results. I want more results. Now give me just the ones that start with 0.9. And now I get the 90% ratings as well. And if I wanted to get all the 80% and above ratings, I can get the ones that start with 0.8. And so everything about, obviously, we could do these link tags in much more compact binary representation because it's just a series of bytes. Why do we do it in UTF-8? One reason is for debuggability, so that we can easily see in tools the link tags spelled out for us. And the other reason, like the reason we spell out these numeric values, is so that we can search as just described. Also in this example, we see that there's additional attributes in an entry in the first set of link tags, and they point to the same additional attributes naturally as each other. In the second example, the person making this rating had no additional attributes, and so there's no need for that additional entry. And then lastly, we see an example of spam as a negative rating. And worth noting that even when this is 100% and this is, negative 100% all the way down and all the way up, we represent them as 99999 again, so that we can search on them. And that wraps up what I wanted to show you today. To see more of the TrustGraph project, check out trustgraph.net. This deck will be available at /FOSDEM 2020, and you can follow me on Twitter at Harlan T. Wood. Happy to take any questions.